Hello, Miss Winelander here, and today I'm going to go through the Systems of Linear and Quadratic Equations quiz. So it's Algebra 1B, Unit 4, Lesson 8. So in this recording, I'm going to go over the problems in the original quiz so you can help find your mistakes when you look over your paper, or if you weren't writing down your work in the first place. It can help you kind of think about how you can approach these types of questions. Also, at some point, I'm going to say that important secret word. Remember to pay attention for that word. That's what you enter in order to earn your retake. So for question 1, it says solve the systems of equations. So just like you remember solving from last semester, you can solve using elimination or substitution. In this case, since I saw they were both equal to y, I thought of substitution first. So I thought I'd substitute one into the other. So here I'd substitute y is equal to 2x squared minus 3 into y. So I'd have 2x squared minus 3 is equal to 3x minus 1. And I'm going to start solving. So let's see. I'm going to try to put all the variables on one side of the equation here. So I can subtract 3x from both sides. Since there's no like terms here, I got to keep them all separate, but I do write them from the greatest exponent to the smallest. 3x minus 3x is 0, so we just have negative 1 left here. So now I can add 1 to both sides to do equal but opposite. Negative 3 plus 1 is negative 2 equals 0. Now that I have it equal to 0 and I have a quadratic, I can think about, well, let's factor this quadratic. Let's see if it can be factored. So remember, you're thinking a is 2, b is negative 3, c is negative 2. A times c, so is 2 times negative 2, or negative 4. So you can make that table. You want to make sure that you have factors of AC, so factors of negative 4, that add to b, in this case negative 3. So factors of negative 4 could be 1 and negative 4, negative 1, 4, 2 and negative 2. Those are the only ones I can come up with. So when we add 1 and negative 4 is negative 3. Just to double check, we'll make sure that these don't quite work out. Yep, so this is the one that we're going to go through and do. So when we have our 2x squared minus 3x minus 2 is equal to 0, we know that our middle term, negative 3x, we're going to split into those two factors there. So we have 2x squared plus x minus 4x minus 2 is equal to 0. I kind of think about these two groupings here. Think about the greatest common factor. So here the greatest common factor is x, because they can each term can be evenly divided by x. When you do that, 2x squared divided by x is 2x. X divided by x is 1. The greatest common factor between negative 4x and negative 2 would be negative 2. So negative 4x divided by negative 2, negative 4 divided by negative 2 is positive 2. X, negative 2 divided by negative 2 is 1. And it's a good sign that those two are the same. So now we know our two factors. That's one of them, and the other is x minus 2, because you're thinking, well, rather than write them separately, you can kind of undo the distributive property, kind of think of it that way, and you can say, well, I know that I have to multiply x minus 2, 2x plus 1. Still equals 0. So now we can use our zero product property. So we know that the only way when two things are multiplied by each other to get to 0, one of them has to equal to 0. So 2x plus 1 equals 0, or x minus 2 is equal to 0. We'll solve for those using inverse operations. So we get x is equal to negative 1/2, or x is equal to 2. So those are our x terms. Remember, we're solving the systems of equations, and these systems have x and y, so we want to make sure we substitute both x values back in order to get our value for y. We can use either equation, so I'm going to use that kind of second one there. So we have y is equal to 3x minus 1. Well, one of the x's is negative 1/2, so 3x times negative 1/2 minus 1. So negative 3 times negative 1 is negative 3 halves minus 1. So we can also think of minus 1 if we kind of think of common denominator is negative 2 over 2, because 2 over 2 is 1, but that gives us that same denominator of 2. So then we have negative 3 minus 2, negative 5. So negative 5 halves. So one of our values is when x is negative 1 half, y is negative 5 halves. Our other value is going to come when you substitute in 2 for x. So we get 3 times 2 minus 1. 3 times 2 is 6 minus 1. 6 minus 1 is 5. So our other one is when x is 2, y is 5. And those are our 2 points, or our 2 solutions to this system of equations here. Now, if you didn't solve it this way and you used elimination or graphing, that also functions, but you should get the same final answer. Your process just might look different. Question 2 says, how many real number solutions are there to the equation 0 is equal to negative 3x squared plus x minus 4? So one way that you can find this is using the discriminant. Grab my pen here. Alright, so if you remember, the discriminant is b squared minus 4ac. If it is greater than 0, then that means that it has 2 solutions. If it is exactly equal to 0, it has 1 solution. And if it is less than 0, it has no solutions. If you're kind of thinking about a quick graph here, if you have your coordinate plane, 2 solutions means that it crosses that x-axis twice. So it might look something like that, because those solutions would be right there. For 1 solution, it means it just crosses that x-axis once, so it might meet right on the x-axis. For no solutions, it doesn't cross that x-axis at all. So for how many real number solutions this one has, we want to figure out our a, b, and c and substitute those in. So remember, a is the coefficient of x squared, so that's negative 3. B is the coefficient of x, or in this case 1. C is the last constant, negative 4. So substitute that in. So we have b squared minus 4ac, or b in this case is 1. So 1 squared minus 4 times a, negative 3. C, which is negative 4. When we simplify, 1 squared, 1 times 1 is 1. Negative 4 times negative 3 is positive 12. Positive 12 times negative 4 is negative 48. So we have 1 minus 48, which is negative 47. Since that is negative, it has no solutions. Remember, these are talking about number of real solutions. So you'll figure out in a later class, it does have solutions, they're not the real numbers. For number 3, it says solve the equation by completing the square. If necessary, round to the nearest hundredth. For some reason the equation isn't there, so let's see. I'll write it down again. We have x squared minus 18x plus 80. Oh. Alright, so we have x squared minus 18x is equal to 19 here. So by completing the square, we want to figure out what can we add to both sides of the equation to maintain the equality, but to make it so that left-hand side can be factored. So how you can do that is you look at b divided by 2 squared. So remember, in this case, a is the coefficient of x squared, so in this case 1. B is the coefficient of x, which is negative 18. C is 0, in this case right here. So b divided by 2 squared would be negative 18 divided by 2 squared. Negative 18 divided by 2 is negative 9 squared. So negative 9 times negative 9 is 81. So that's what we're going to add to both sides here. So again, let me erase that there. We have x squared minus 18x, and then we're going to add 81. And we have 19. We have to add 81 on this side too, so we maintain that they're equal. When we do to one side, we have to do the other. But now we know that we can factor this. We know that it can be factored to x minus 9 squared. That minus 9 kind of shows us. That equals 19 plus 81, so 100. Now we can solve that. So we can take the square root of each side. We have x minus 9 is equal plus or minus 10 here. So now we kind of have two options. So sometimes I rewrite them right here. I have x minus 9 is equal to positive 10, or x minus 9 could be equal to negative 10, because remember, either of those, when you square them, you get to 100. So in order to solve, we add 9 to both sides. So 10 plus 9 is 19. Add 9 over here. Negative 10 plus 9 is negative 1. So our two responses are negative 1 or 19. Alright, for number 4, it kind of looks similar to what we ended up with at the end of last problem here. So we have that x squared minus 81 is equal to 0. We can add 81 to both sides. We get x squared is equal to 81. When we square root, we get x is equal to plus or minus 9. Remember, because 9 squared is 81, but so is negative 9 squared is equal to 81. Alright, the next problem here is number 5. So which model is appropriate for the data shown in the graph below? So we've kind of covered some main ones. We've covered linear. Those look like, straight lines. They can be positive or negative slope, zero slope, undefined slope. We talked about quadratic. Those kind of what I think of, they look like almost like U's. We've talked about exponential. Ooh, sometimes I think of those as like J's. So let's think, which of these models look was the most appropriate? So if we were to kind of connect the dots here, that looks like exponential. So that's the model that is most appropriate, that fits this. It doesn't ask us to come up with the equation, so you don't have to do that. For the next group, we're going to match. So I kind of included each picture on each slide so we can go through and match them. Before we do that, I just want to let everyone know that the secret word for this video is positive. So remember, stay positive, and in order to earn the retake, enter in positive into that Google's form, and then we'll send you the retake. So for number 6, we have y is equal to negative 2x squared plus 2. There's many ways that we can match the graph. So if you can go through the axis of symmetry, which I think Mrs. Hool writes as AOS. So remember, that's when x is equal to negative b over 2a. So in this case, b is that coefficient before the x term. There isn't an x term, so it's 0. 2 times a is the coefficient of the x squared term, so that's negative 2. So we have 0 divided by negative 4, or 0. So axis of symmetry is at 0. It does look like that's not super helpful for us quite yet. Let's see, we could do the vertex. That's when you can substitute in. So when x is equal to 0, what is y? So in this case, it would be negative 2 times 0 squared plus 2. Negative 2 times 0 plus 2, because 0 times 0 is 0. Negative 2 times 0 is 0, plus 2. 0 plus 2 is 2. So the vertex is at 0, 2. That might help us more. So let's see, 0, 2. So that could work out. 0, 2. This one can't. 0, 2. Not this one, and not this one. So just from that information, we can jump to right away. We know that graph A matches. For the next question, question 7. Again, we're matching the graph. So we can think of it the same way. Maybe the vertex helped us last time, so maybe let's see if the vertex can help us this time too. So when x is equal to 0, let's substitute that in and figure out what y is. So y is equal to negative x squared. So negative 0 squared. So 0 squared, so 0 times 0 is 0, so negative 0. Negative 0 is the same as 0, so our vertex is 0, 0. So 0, 0 is right here. Doesn't match this first one. does match B. 0, 0. Could be C. Could be D. Alright, so now we gotta think about which one is gonna be more likely to make the shape. Another way that you could always graph things, no matter what situation it is, whether it's modeling linear, quadratic, exponential, quartic, anything that you see later on, you can always make a table of values. So you can always make your x and y. So there's some differences here. We know another term would be when x is 2, y is either going to be in positive or negative value. So let's see, when we substitute in 2, what does that get us? Y is equal to negative 2 squared. So 2 squared is 4, so negative 4. So we go 2 to negative 4 is going to be right here. 2 negative 4 is going to be right here. So it's looking a little bit more like D here. Let's just kind of confirm that. We can try another response. Maybe we can try when x is 1, so y is equal to negative 1 squared. 1 squared is 1, so negative 1. So when x is 1, y is negative 1. Oh, negative 1. Yeah, it's looking like D is the answer. So D is the best match in this case. For number 10, we're still doing the same general idea. We're just trying to match. So let's start with our vertex again. That's worked out at least a couple times to help us eliminate. So when x is equal to 0, what's y? So y is equal to 2x squared. Substitute in 0 for x. Follow order operation, so 0 squared. So 0 times 0 is 0. So 2 times 0. 2 times 0 is 0. So our vertex again is 0, 0. So since that's right there, A does not work out. B doesn't match. Still could be C or D. Now we eliminated D in the last question here, but we're not maybe 100% sure that they didn't give us an equation that matches the graph, the same graph. So let's just make sure. Let's make our table of values again, just to check. So we can check the same idea. Maybe we can check 1 and 2. So when x is 1, y is equal to 2 times 1 squared. 1 times 1 is 1. So 2 times 1, 2 times 1 is 2. So when x is 1, y is 2. So x is 1, y is 2. X is 1, y is 2. So it is looking like it's going to be C. Let's just confirm that again with another point just to make sure. So we substitute in 2 for x. 2 squared. 2 times 2 is 4. 2 times 4 is 8. So when it's 2, 8's going to be like off the charts over here. It does match out. So C looks like the best match in this case. Number 9, again, follows the same general pattern. So let's try our vertex. So when x is equal to 0, what's y? When y is 3x squared minus 4. Alright, so 3 times 0 squared minus 4. 0 squared is 0 minus 4. 3 times 0 is 0 minus 4. So we got a point 0, negative 4. So 0, negative 4. So not A. 0, negative 4 could be B. 0, negative 4, not C. 0, negative 4, not D. So we're leaning immediately to B. It's never a bad idea to just kind of double check your response just to make sure, so we can substitute in maybe 1 and 2 again. So we have 3 times 1 squared minus 4. 3 times 1 minus 4. 3 minus 4, negative 1. So 1, negative 1. Oh, that does seem to match. With 2, we would have 3 times 2 squared minus 4. 2 squared is 4. So 3 times 4 is 12 minus 4. 12 minus 4 is 8. Oh, it jumps really fast. So 2 and 8, that does kind of match because 8's going to be kind of off the charts here. So it does look like pretty confident that B is the best match of that graph. Number 10 is our last question here. So it says graph the quadratic functions y is equal to negative 2x squared and y is equal to negative 2x squared plus 4 on a separate sheet of paper. Using those graphs, compare and contrast the shape and positions of the graphs. So let's see. Let's kind of make 2 sections here. And let's start maybe with a vertex in a table of values so we can start these graphs. X and Y, X and Y. So let's maybe do 0. So when we have 0, we have negative 2 times 0 squared. 0 squared is 0, so we have negative 2 times 0. Negative 2 times 0 is 0. So over here, our first point would be 0, 0. Let's try a point 2. So we have negative 2 times 2 squared. Negative 2 times 4, or negative 8. So when it's 2 over, we go down 1, 2, 3, 4, 5, 6, 7, 8. All right. Now, I like to think that it has a perfect kind of mirror there, but let's just make sure our axis of symmetry works out. So, axis of symmetry, remember in this case, is x is equal to negative b all over 2a. So, b in this case, there is no x term, so it's 0, so it's going to be negative 0 all over 2 times coefficient of x squared, which is negative 2. So we have negative 0, which is the same as 0, divided by 2 times negative 2, which is negative 4. 0 divided by negative 4 is 0. So our axis of symmetry is at 0. So we can know that this is like kind of a perfect mirror image here. So this is going to be kind of the general shape of our quadratic. Maybe we can move it over a little bit too. I kind of got a little messy in my lines there. Let's see if I can do a better job. Alright, let's see what the difference is between y is equal to negative 2x squared plus 4. Let's do 0 again. So we have negative 2 times 0 squared plus 4. We already know that negative 2 0 squared is 0. So we know we have 0 plus 4, or 4. So 0, 1, 2, 3, 4. When we substitute in 2, what happens? We have negative 2 times 2 squared plus 4. Again, we know this kind of first piece is equal to negative 8, so we know negative 8 plus 4, which is negative 4. So 2, and we have 1, 2, 3, 4. Let's see if our axis of symmetry is the same idea. AOS. So that's equal to negative b all over 2a. So in this case, b is still 0, so negative 0 all over 2. A is still the same at negative 2. So it's going to have the same axis of symmetry at 0. So we know that we have that kind of matching point over here. So let's think. What are the similarities and differences between these two graphs? Because we want to compare and contrast. I would say for compare, for the same, they're both facing down. We know they both, there we go, they're both facing down. It looks like they both have the same, almost change, same rate of change, almost like the same slope. Their shape is the same width. That's about the similarities that I see. For contrast, so what's different, I noticed that the y is equal to negative 2x squared plus 4 is shifted 4 up on the y-axis. So I would say that it's up 4. And I would be comparing and contrasting these graphs. You would want to type that out. So now that you have a better idea of how to answer these 10 questions, hopefully you found some of your mistakes. If you feel ready to take your retake, type in that secret word in the Google form and we'll send it to you. If you still have questions, then reach out to myself, Ms. Weinlander, or Mrs. Hool. Either way, talk to you soon. Bye.